Hello, everyone. My name is Matt Barami from Wolfram Research. I would like to welcome you to the first session of our live coding series with Mitch Stonehacker. We are very happy to have Mitch as our instructor. Mitch will do live demonstration of key features of Wolfram language that are very useful in building Wolfram Cloud APIs to JavaScript. I would like to add that Mitch has been using Wolfram language from version 2 in mid-80s, a long time ago. His work experience is quantitative and operational financial market. Most recently, he has used Wolfram language, Wolfram Cloud, JavaScript, AWS to set up christyhealth.org and other websites. These websites are not micro websites and require full-state front ends, serverless backends, and a computational engine for sophisticated computations and image creation. During the first session, Mitch will focus on JSON and images. Without further ado, let us welcome our instructor, Mitch.
Thank you, Mats, and welcome to everyone. Happy to be here. So the preceding live coding sessions are really important, and I'm not going to cover anything that they've done. I think the work that Andreas and Al Calvidia have done with regard to data sets and some of the best practices kinds of coding that can be done in the Mathematica notebooks is really, really helpful. And I'm going to focus very much on in the area of how do you, once you have something ready to go, how do you go about putting it into a browser, for instance, into an API? How does this become usable in something outside of the Mathematica notebook or the Mathematica Wolfram Cloud interface? So how this came about for me is I've been involved with a number of websites. One is one called AITO Consulting, in which there's a front end capability, and I'm just going to really quickly go through this, where you can enter in certain variables into what is, in fact, when you get down to it, a very complicated equation. Although there are packages in all kinds of languages to calculate this, but this is all being set up so that it's hitting Mathematica on the back end from an API call. So you can see that as I go through here and change any of this, let's say I want a European type option, then everything gets recalculated according to how I'm interacting with the user interface. And from the user perspective, I don't need to see anything else that's behind the scenes. But of course, we want to know exactly what's going on behind the scenes. And so there's a couple of ways that we're going to look at this, and we're going to be producing some of these API calls to produce this kind of user, to produce the back end computational piece of what fits to what is connected up to this user interface. We're going to be using JavaScript, and I use a lot of React JavaScript to connect directly to this. And I'll walk through a little bit of this JavaScript just to make sure that people are understanding, how this might fit together. And hopefully this is, making a lot of sense by the end of it, how all of this is working, or people have some experience with JavaScript in particular and how this fits together. But that's the game plan. Now, what I've got going, I'm sure, is going to take more than an hour. Or what I've got planned in the entire scheme of things is certainly going to take more than an hour. So we're going to go as far as we can get in an hour today, and then we'll drop off and we'll pick up in another session. But because the total objective here is to interact with a purely JavaScript front end, React, to using a API, Mathematica API function, both for JSON objects and returning those JSON objects into a browser, but also to be able to return from an API function call images as well. And we'll get into images a little bit. It probably in the next session we'll get into how we would make the same kinds of calls, but going through a node server. And then at some point, we'll get into how we're hosting that node server in AWS to be able to call these Mathematica API functions. And the primary motivation for all of this boils down to the fact that in any substantial development effort, there's always a separation, and in any large body of code, there's always the separation of duties, with regard to the team, but also with regard to the code. So that there's, I always break it down into the front end, the back end, and the computational side. And so some people are really good in any of those, and in the end, it all has to get put together. So we're going to be initially looking at the front end and the computational side to be able to see how that interface can happen in a pretty straightforward way. I'm not going to get into the how do you get Node set up, how do you get npm set up on your machine. There's a lot of good material out there on Google that you're going to be able to get yourself set up if you haven't set that up on your systems already. And by the way, everything that you're going to be seeing here, the underlying notebook that I've put together for this is going to go to my GitHub at some point in the next couple of days. I don't quite have it ready yet. So happy to take questions at the end, leave some time. But in the meantime, I'm simply going to step through the sequence. To start off, I'm going to step through the sequence of steps that I go through, that I've learned, taught myself to go through to get things off and running in a good way that's fairly consistent and captures as many bugs as possible, as many problems as possible, right off the bat. So I always start off with, in almost every section of code, I always start off with a clear all on whatever variable I'm going to be using in that section of code. So I'm going to start off defining something, API, which is using the API Mathematica function, right? And I always tend to just not write all of the code on one one line of code. I rather use my Mathematica sort of like I write the JavaScript. But at any rate, in this first case, what we're going to do is we're going to just create an API function that takes no arguments in the URL string and simply returns a random integer. All right. So what that means from the API function call is that the first part of API function, which is get the inputs and interpret the inputs. So in this case, we have no inputs, so that's just an empty list. And what we're going to do then is we're going to create the function block, and that function block is simply going to be a random integer. And in this case, we're going to define that random integer to be, we're going to hard code that random integer to be between -10 and 10. And then what we're going to do, the last part of an API function call, is to tell the API function call what format you want to return this thing in, this result in, and we're going to return this in JSON, right? So if we and I can see, there you go. That'll fix that. And so when we're there, then we return that, and you can see right away that what API is it's the function, right? That's pretty much exactly what we expect. So if we go API, so we can test this function by giving it some input, but of course this first function has no input, so it's expecting no input. So we expect it to return, we expect it to go directly to the function and return something like that, right? And every time we hit this thing, we're going to get some result, right? So that seems to be working just fine. Now now we have to cloud deploy it, so we're going to clear all, and I always use, my habit is to use CD as a label. So we're going to cloud deploy, and we're going to pass into cloud deploy the API function, which is exactly this function right here. So that's what cloud deploy is going to be processing. And what we're going to do then is we're going to, the next part of a cloud deploy is I always give it a specific path that I want to pass in here. So I'm going to define live coding and random integer. Now, the thing that's interesting here is I am passing in exactly the URL string segment that is being used by this JavaScript to create this API in this local host. All right, so just sort of thinking ahead a little bit. Now, the other part of the cloud deploy is setting your permissions correct. And in this case, I'm just going to set all permissions to public, and that's going to give us the URL, the base URL here that you can click on if you want. And in this case, it's going to work just fine because there's no parameters that you're going to be passing into. Which typically there are parameters that you pass into. So I'm going to skip just the click on that, but it's definitely possible if you're following along with this to go do that. And so what I'm going to do now is I'm just going to clear all, and I always create a URL and a session variable, because the URL is going to be a URL build where we have the cloud deploy object and some test input, which again, remember, for this first API, the test input is just nothing. And so what we're going to do now is we're going to define a session in which what we can do is we can start, I guess I need start a web session. There we go. And I tend to like Chrome quite a bit, so I'm going to start a Chrome web session. And once we have both the URL defined and the session defined, what we can do is we can do web execute. And in our web execute, we can say, well, I want to use that session, and I want to do something like open page, where the open page goes to URL. Now, when you do that, what happens, and this browser opened on my other screen, so I'm going to pass it over here. When you do that, what happens is Chrome opens for you a session in which you can start, playing around with this URL. Now, we have no input parameters here, so all you have to do is just refresh the browser, and you're interacting with your API already. So I'm just going to kill that session, and that's the general pattern that we're going to go through in our process. So I'm going to switch over to the JavaScript just to show how this gets integrated into a JavaScript, in particular a React page, single page application. And the way that I'm doing this is I have in a file called utilities APIs, two variables called the base URL and the endpoint, which, as you can see, is going to be composed of various pieces, right, of this string. And then up here in the body of what I'm working on, I'm saying I want this. This is actually a different URL, sorry, but at any rate, a Wolfram function, the Wolfram function, the Wolfram Cloud function that I'm actually going to be calling. And then what I do is inside my API call, which is exactly this little bit of a string here, I'm actually parsing together the bits and pieces of the string and in this case, this actually is a future API call that we're going to get to in a bit. But this pieces together the string that gets called, and we're doing this inside of a try-catch block, and we're doing that with some additional conditionals to make sure that the variables X and Y, which are set down in the form block, which I'll get to in a little bit, that they actually exist, because React is asynchronous. You have to be a little bit careful of how you're managing state and the conditions on which you're calling an API. The last thing in the world you want to do is get yourself into a situation in which you're continuously calling indiscriminately this API. That would be not so good. All right, so that's the general pattern, and I'm going to go through this a couple of times so that the pattern comes into good focus. So again, I'm going to clear the API because of the prior API. I'm going to define a new API, where API function, and in this case, we want to have two inputs. What I want to have is an X input where X is interpreted. There you go, is interpreted as an integer. So this is very helpful. This capability is very helpful because it allows us to manage on the receiving side, and I also want another variable called Y, which is also an integer. But this allows us to interpret this from the back end, from the computation side, to be able to make sure that what the front end is passing us is exactly what we expect. I'll talk more about failures in a minute here. So we want our function block. And in our function block, we just want we're just going to use the random integer again. And in this case, what we're going to be using is our parameters. And the way that we can do that is just say we want the random integers be between X and Y. And we want that result to be in a JSON form. So we'll come down here and we'll say, for testing purposes, we want to be able to say, we want our X to go to, let's say, -5, and we want our Y to go to 5. All right, so there you go. And if we re-hit that again, we should be able to get any integer, random integer between -5 and 5. Now, the nice thing about the way that we're going about all of this is there's a lot of this that can just be copy pasted at this point, right? So now we're going to want to rename this a little bit because this is actually a different API that we're going to be deploying. But there's no reason why we can't just copy paste this so that we can become a little bit more efficient about how we're going about this. Now that's interesting. Wait a second. Of course. Now that's interesting. All right, actually, let's do this again. Let's do that again, because this is one of the failings of copy pasting everything. You see, we got a false here on our output, and the reason why we got a false is because, and I'm going to get more into this a little bit later, is because it's expecting X and Y. So why doesn't it know about X and Y? It's because I sent over the empty set, right? So we definitely need to test this with X and Y, which, let me kill that session. And if we test with X and Y, there we go. We have our random between between 5. And now this is where you can start to come up to your URL, and you can just say, all right, you know what, I want the random integers to be between -50 and 50. And so now you're on your way, right? So so now what we want to be able to do is we want to be able to start handling some of these failures, or we want to start to think about how we handle some of these failures in a good way. So as I mentioned, this URL, this API right now is set to look between is set to look between 5 and -5 and 5, right? So if we pass in something that is inappropriate, out of bounds, right, we're going to get this failure. Now, the interesting thing about this failure is that if we pass, there is this. All right, so if you click into that, you see this failure message actually has parameters, and we can get these or message results, and we can get this information out of this fail message, which is extremely convenient. So for example, if we say, well, you know, give me the message template, the interesting thing about being able to capture this message template and potentially, and I typically do, pass it back to the JavaScript side is the fact that you can start to do error handling, right? So if you're in your try catch block, and the API fails, then you can actually pass this error message back to your JavaScript error passing, your error capture process, and the front end guy is going to be able to see in this case in their console log, right? It's going to be able to receive your error message. Now I'm not going to show that. The important thing is that the API function is going to be able to allow you to give feedback to the front end guy exactly what the message is. Now, what's really also interesting about this is you can pass back exactly what's going on here. So for example, the failure fields were both the X and the Y field. So for example, if we say, you know what, I want that to be, you know, -3 to 10, then it's only the Y field that is failing. Okay, so this kind of this feedback again can be passed back to the JavaScript side to be able to let the downstream systems know exactly that it was the Y variable that was failing. Now, this is very good, you know, handshake kind of good neighbor development-wise kind of stuff that we want to be able to incorporate between the computation side and the JavaScript side. So now I'm going to at this point, I'm trusting that you're getting the pattern of how I go about building out these APIs in a way that I'm going to spend less time actually typing in the code and more time just starting to walk through the code a little bit. And then we'll go through some of these testing exercises a little bit, because I think that I want to make sure, for the sake of time, that we get into a reasonably good level of dealing with JSON objects in the Mathematica side, and how they get dealt with, how they get used and consumed on the JSON, on the JavaScript side. But first, I want to get into a particular scenario which I've found comes up from time to time. First of all, in dealing with real numbers, right? Mathematica knows how to deal with real numbers very well. Other computer systems and languages don't. JavaScript is one of those that doesn't. And so what you want to do, what I find most helpful, is to deal with the nuances of dealing with reals on the Mathematica side, sending in the JSON object over to the JavaScript side exactly what JavaScript is expecting, and don't leave it to chance, right? So in this case, what we're going to be doing is we're going to be having an X and Y that are to be interpreted as reals, and we're going to pass the X and Y to a random real, and then what we're going to do is we're going to round the results to 3 decimal places, and we're going to put those into string format. All right, so if we use that, then what we're doing is we're getting a bunch of reals here that are between 1.1 and negative 1.1 and 1.1. And so we can easily copy paste from our prior sessions. And in this case, I'm renaming this endpoint path random real. And if we get into our testing mode, into our session, build the URL. We're going to build the URL. We're going to start a session, and we're going to web execute that session so that we can look at it in the browser, right? And what we see is we've got a string here. We've got a string formatted. We've created a number, a real number, rounded to the third decimal place in a string form, and that's pretty much not going to fail on the JavaScript side. So that's all very handy. So there's another aspect of testing that I want to get into a little bit. And again, for the sake of time, I'm going to copy paste in and then walk through what I'm doing here. So what I want to do is I want to test 100 times, right, this API. This is exactly the same API that we've created up here, right? We're just using that API. We're going to test this API, and we're going to run it 100 times. And what we wanted, and what I'm doing is I'm saying, I want to run that 100 times. I want to find the string length of the maximum item that we're pulling, that is being generated out of this 100 iterations, right? So first of all, what's happening is in less than 1 second, we've run that API 100 times. And the maximum string length that we got out of that API is 6. Now, does that make sense to us with regard to the fact that we have said I've limited how many decimal places I want to carry this to, which is 1, 2, 3, and the decimal is 4, 5, and it can be a negative number, 6. So that's exactly what I'm expecting. I'm expecting the longest string length to be 6, which is exactly what I got. And it took me less than 1 second to test this 100 times. Sounds like I'm pretty good to go. All right. So now I want to get into what I want to do is switch gears a little bit, because what we've been doing is we've been testing on a single output, and expecting the JavaScript side to be able to handle a single output. Well, of course, that's a pretty trivial case. And so what I'm going to do now is I'm going to start to get into JSON objects, and particularly on the JSON on the JavaScript side. Let me get JSON object. Actually, let me do this. JSON object 1. All right. So this is the code set for this guy. And what we want to be able to do is set things up so that on the front end side, let me stretch this out just a little bit. On the front end side, what we're doing is we're passing in the URL to our function call. Oops, our API is over here, where we call the API is over here. So we're passing in all of the parameters for our API call in React, right here. The X, the Y, and the Z. Z being how many random numbers do you want between a range of X and Y. And so we're going to pass that in, and what we're going to get back from that, actually I should say right here, what we're going to get back from that is something called result, and result returns a data object. That data object, because we're using Axios as a standard for Axios, that data object is actually a JSON object. Now that JSON object is going to be used down here when what we do here is we say, well, I've got my data object here, and what I want to do is I want to map on data all of the items in data. And we're going to be taking every one of the items that are in data, and we're going to be creating the HTML for displaying that. So you can see how efficient from the JavaScript side dealing with what could be a very large JSON object becomes, right? It's just that little bit of code. But the primary consideration about returning that JSON object is that we need something, an indexing value to be returned in our JSON object. And so that's one of the primary things that we're going to be looking at now over on the Mathematica side with regard to how we prepare a JSON object to be immediately consumable over on the JavaScript side. And so what we're going to do is we're just going to set up some test X, test Y, and test Z, which are the minimum, maximum of a random pick range, and then I want 10 of those items. So that's what we're going to be doing. So the way that this is going to look from the Mathematica side is I just want a range, right, of test Z number of items. And I'm just going to call that ST. And I want to be able to put together a random real between test Y and test Z, test X and test Y, test Z number of times. And again, I want to do that round and toString in order to prepare it for consumption over on the JavaScript side. So you see that what we have now is we have a list of two things, this being the index that we're going to be using, and this being the set of random numbers that we actually want to be able to push through. And the way that we're going to put those together is this simple. We're just going to use association thread and pass ST and RN through there. And now we have our what is in a Mathematica association, and we have the first bit of exactly what we want to build our Mathematica side. Now, one of the things that I have done in order to, because Mathematica is so good at creating functions, one of the things that I've done is just created a little function which compacts into a single function the two steps that you're taking in all of this. One is to round some number to some level, right, and make it a string, right? So when we process that, right, we're going to be able to get some number back rounded to three levels. Now, and the reason why is because in order to put this in what I consider to be a JSON object ready Mathematica association, this is what I actually need, right? I need to create an association in which I'm defining two things, the index and the value. So we know that we have, in this association thread, we had the index was the key in the association for the value. But that's not exactly what we want over here on the map side, because we want to be able to pull out the key in a really easy way. Now, there are ways in JavaScript to be able to pull JSON object keys and then JSON object values out of something like this, but it's just much easier to be able to deal with this on the JSON side if what you're giving this thing is the index that the index itself, as well as any and all of the values that go along with that index. So again, what we're going to do then, what we're going to do is I'm going to copy a code block over, and I'm just going to drop this. Again, for the sake of time, I'm going to I had thought of maybe iterating through a couple of scenarios to sort of build up the evidence of why we're going through this process. But nevertheless, the consideration then is that we're going to, in this case, have an API API function in which inside this API function I'm actually calling a which because there are in fact 3 cases that I want to be able to show. All right. So again, we're using the API function. So first of all, if you're not familiar with doing something like this, I found this to be extremely helpful in certain rather advanced situations in which you're making what, for all intents and purposes, is a modular component here. But nevertheless, we're passing 2 reals, x and y, which gives us the high and low range from which we're going to sample random integers, and we're going to pass an integer z, which is telling us how many times we want to sample random integers. And then what I'm going to do is from the which, if we look here, obviously what we're going to get here is some number, in this case 10, random samples between, let me pick negative 1 and who cares, 1, 2, 5, right? And we're just going to take that 10 times. And what you can see here is, first of all, we certainly do get a list of 10 random numbers between our range, but you can see on the Mathematica side what's being returned to us. Data set doesn't quite get us. Data set, let's put it this way: it's an association. Under the hood, this is an association, which is fine. It's usable. It's completely okay. It's just that I want to work with it in a full-on data set way for reasons that I'm going to get to in just a second. The second scenario is okay. Now we have applied our get the sample, round it to 3, make a string out of it, etc. So these are actually strings, a list of strings now, and that's just an association of strings now, all rounded to the 3rd decimal place. So that's okay. But this is what we really want to return. What we really want to return is the index and the value rounded using the round to string function, in which case what we now have is we have a good-looking Mathematica type data set where we have the index and the value, and we can work with, if you recall back to Andreas's and Al's utilization for data sets, you can start to see how in the function of our API function, right? Or maybe what I should be saying is that we can create functions outside of our API function that are used inside of our API function, which produce data sets in exactly the way that we want to both send off a JSON object for consumption on the JS side, but is also completely usable on the Mathematica side as a full-on data set. So this I have found to be extremely convenient to start to sort of think about how this all happens in a single sort of way. All right. So, and from here, we just carry on. And again, I'm just going to copy paste. And here we're going to use our 3rd scenario. And here we're going to be calling it random array 1. And then what we're going to do is we're just going to build our URL. We're going to create the session, and then we're going to web execute the session so that we can see it in our Chrome browser. And sure enough, let me move it over here. Sure enough, this is exactly what I expect to see over on the JavaScript side for a well-formatted JSON object that I know is going to map very, very well in JavaScript using the map function, so that over on the JavaScript side, it simply is that trivial to put that data into good form. And let me just show you that form. Let's see. Yes, I think it's this one. So if we were to do something like and 1.2. Oops, let me go back here because I actually wanted to have that be negative 1.2 and 1.2, and let's say 20 samples, and you mark it, set, go. Then there you go, right? It just becomes extremely trivial on the JSON side. Excuse me, on the JavaScript side to bring back however many of these you wanna bring back. It just kind of doesn't matter, right? So this is all really easy on the JS side, and that's what we're after. That said, not only being easy on the JS side, the point is that we also have this data set object over on the Mathematica side, which is they're going to be the same thing. So pretty cool. Now, there's a couple of so I bumped into an issue that I'm going to walk through, which is a little bit interesting. Let's put it that way. It took me a while to sort of debug this. So it turns out that the expression of -0 is 0, right? Oh, all right. Well, that's in mathematical world. That's just totally fine, right? The problem is that if you want to do things with strings, right? Where, for instance, if you want to turn numbers into text or numbers into language, then Mathematica has this function called integer name, which if you say 125, Mathematica says, yeah, that's 125. I know that to be 125. But look what happened. But look, wait a second, that's not an integer, right? And the problem is that Mathematica doesn't have a real name, right? Like it has a integer name. So it turns out I bumped into a situation in which I had to actually create something that was going to be able to deal with turning a real number into English language in this case, right? Which could then be used subsequently used in text messages or spoken, right? So you've got to be able to reconstruct this in using real words if you're going to parse it that way. So that's the scenario that I bumped into, and so boy oh boy, I'm going to copy paste and walk through the code here because this starts to take a little bit of time. Now, what you're going to see here, especially given this thing called real string, which is this negative, very small, less than 0 number, right? Less than 0, but also less than -1, right? Number is which if you were to apply, well, let's put it this way. First of all, remember, integer name isn't going to work on this. And so you've got to find a way to parse this thing and make sure that you're not losing track of the negative sign. So you obviously can't pass to expression across this list of, in order to do that. So you have to be able to come in and find out if the first element, right, is a negative sign. And obviously I'm putting all of these into strings. If the first element is a negative sign, then we actually want to apply the word negative with the rest, right, of the items that are in that, and then we're going to string join that, and we're going to call to expression because we now have, right, an integer name on that. And we can then apply L and string join expression, integer name, et cetera, et cetera. So we then have the right-hand side, right? We have that side of this thing that we're working with. And then we're going to deal with the left-hand side, and et cetera, et cetera. When we put the left-hand side and the right-hand side together, we're going to inject the word point between the left-hand side and the right-hand side. And then we're going to rifle a space between each of those items and then string join it so that we have some, nice English language read kind of thing. Then what we're going to do is we're going to create a single function, which is number name, in which we can either pass a real thing, a real number, which if we pass a real number, you see what's happening is we're going to call our function here, our special function here. But if the name number is actually an integer, then we're just going to let Mathematica do its thing with integer name. All right. So we've jam-packed that. So what we're going to do is we're just going to do a little bit of testing on this to make sure that we're thinking of this the right way. And make sure that we're okay, string split characters. I got to make sure that I'm not losing track of myself here. Yes, okay, so we have this real test number up here that I've created up here. And this simple test looks like it produced negative 0.001, which is exactly what we're looking for. Okay, so now we want to just build up a little bit bigger test case. And so what I just created here now is a test list in which there's a whole bunch of different kinds of numbers. Some of them are less than -1. Some of them are between -1 and 0. Some of them are between 0 and 1, and some of them are greater than 1. And we just want to process that test list and do the eyeball to make sure that we're getting the leading word negative for all of the negative, right? And that we're getting the point, right, for all of the decimal places. And that we're getting the appropriate number of zeros, right? So negative 0.01, right? So now we have something that is English language, computer readable, in which a text message would be able to send back exactly what this real number is, and a auto-generated voice is going to be able to read back exactly what this real number is. So I won't tell you how I bumped into this issue. I'll just say that it was definitely interesting, and took a little bit of debugging to get down there. Now, if anyone else knows, if I've missed something in the Mathematica language, then please, oh man. But at any rate, now what we want to do with this capability is to create our JSON index value, and in this case, what we're going to define is a name key, which we're going to pass over that our name to number function, right? So what we're doing is this is the index key, this is the value key, and this is the name number key, or the number name key, right? So when we do that, we see, yes, okay, well, this is exactly what I'm after. Now, without even thinking about sending this over to the JavaScript side, what you already know is that because the data set is coming back in this form, I know that on the JavaScript side, the map functionality on JavaScript is going to be able to parse this JSON object in good form. And so when we come down here and we say, negative 1.1 to 1.1 and give me 25 samples, then there we go. And so we can go through here and we can say 0.937, negative 0.021. Yes, that looks like it's working out great. So that's a pretty awesome little thing there. Boy, all right. I did not get as far as I wanted to get at all. So what I'm going to do now is I'm going to wind down by saying that in the next sessions, what I'm going to be doing is starting to look at how, so what we've done so far is we have on the front end side, right? On the front end side, we have passed certain inputs to an API, which Mathematica consumes and sends back a JSON object, which the JavaScript then parses and returns in a nice table in this case, right? So later on, we're going to get to, so we're going to push this scenario one step farther by, rather than sending all of the inputs to Mathematica for computation, in this case, in a random real number, send it, and then producing whatever needs to be produced and send it back. What we're going to be doing is we're going to be giving it some information, and with that information, Mathematica actually has to go out to the internet, pull down something, or out to the internet, could go out external, pull something in, and then with this input and the external input, then combine the two bits and put it and bring it back into a JSON object that is then consumable. The look ahead is down here, but we won't bother to get into it. And as you can see down here, after we've dealt with the case of giving the user interface some input, reaching out to external sources to pull in additional inputs, mix all that up, return back a JSON object, and display that. Then we'll get into graphs, into images, and how we can produce images, return images into the JSON in good form, and the fact that there's different kinds of formats that we can use. And we'll step that a little bit further into images by making sure that the aspect ratio capabilities, both on what you're producing on the Mathematica side, is conforming with the expected aspect ratio of what you need to display on the JSON side, which can be tricky. So there's some best practices, if you will, or what I do in order to solve those kinds of issues. So we'll get into that next time. And beyond that, we'll get into how, the similarities of being able to call this from the NodeJS side, but also then how this starts to fit in with Amazon Web Services, where in particular we're using serverless API calls via Amazon to be able to manage all of this in a serverless way, which I think is pretty cool. But at any rate, let me break off here. If there are any questions, I'm happy to take those now. Matt, do you have anything?
So far, not that much question. One of our users, he, Alan, he had, one suggestion for naming of, real numbers. I just, can you see it? Just
yeah, up here.
Yep. So that's one suggestion that he had. Of course, like if you're planning to use that one has to be careful about trailing zeros. So that was one comment. Yep.
Yeah, right. I mean, the last thing in the world you want to do, right? Nor does it make sense, is to have the point 0, especially when you're trying to describe that number in English language way, for instance, right? I mean, yeah, exactly. That's definitely part of controlling the language, right?
Besides that, let's see, there is no more question. Then in that case, I think that's a very good point to wrap up, today's session. Those of you who are watching us, you were watching the first live coding session with Mitch. You can find the recorded videos on Wolfram YouTube channel. Thanks again, Mitch, for your great lecture, and thanks everyone for watching. Have a good one.
Thank you.